In the previous two videos, I gave you an explanation and an example. So now it's your turn to have a go. So now again, your enemy is standing 500 meters away. Um, but this time you're going to give it more speed. So you're going to fire it at 100 meters per second at an angle of 80 degrees. So it's deeper than last time and it's faster than last time. So the question is, will you be able to hit your enemy? So press pause and have a go. Remember, try to jump to your velocity time graph, and then that will give you an idea. Find out the total flight time. Remember, the total flight time is the same as you firing the cannonball vertically upwards, and then it falls free fall. Well, find out this flight time. Once you've got your flight time, then imagine you and your dad sitting in a car driving at this speed, whatever this speed is. And now that you know the flight time, then you get the flight time times the, well, anyway, do whatever you have to do. Press pause and have a go. Okay, so let's break this up. So break it up. Hang on. The vertical component will be, hang on. The vertical component will be, well, it's like this. This is a right angle triangle. Hang on. So at the moment, you've got yourself a right angle triangle. This here is 100, the hypotenuse. The angle here is 80. So you want to know this here. So this would be a sine. So it would be 100 sine 80. Okay, and then this here would be what? It would be 100 cos 80. That's cos 80. Okay, so now we can visualize the cannonball being fired vertically upwards at 100 sine 80. So now jump to our velocity time graph. So we just want the total flight time. So let's jump to our velocity time graph. Velocity time graph, and it will look something like this. Remember, now we are just looking at the vertical component only. We are looking at this scenario where we are firing the cannonball vertically upwards, and it will get to its maximum height and free fall. So we are just looking at this only. Hang on. So this initial speed here is 100 sine 80. Okay, so the equation for this line is v equals 100 sine 80 take away we're on Earth, so take away 10 t. Okay, now well, normally we find t max, find out the time it takes to get to maximum height. So that would be and well, you put the 0 into the v. So 0 equals 100 sine 80 minus 100 minus 10t. Add 10t to both sides. Add 10t to both sides, and then divide both sides by 10. So that means t equals this. Okay, so hang on, sine 80 divided by 10. So now I'm just going to merge these two together. So that becomes 10 sine 80. Okay, so the time it takes to get to the maximum height is what is it? 10 sine 80. 10 sine 80. That's the time it takes to get to the maximum height. Now if it takes 10 sine 80 seconds to get to maximum height, then if it takes 10 sine 80 to travel from here to here, then just times it by 2 to get this to get the whole total flight time. So now that we know the time it takes to get from here to here, then just times it by 2. So this point here would be this point here. So times it by 2, and then that will give you the total flight time. So get this times 2. So total flight. So flight equals 10 sine 80 times 2. Remember, it's this at the moment is this times a number and then times 2. So let's merge these two together. So that equals 20 sine 80. So this is the total flight time. Okay. Now imagine you. So hang on. Hang on. We are firing the cannonball like this. The time it takes to do this, maximum height, free fall back down, is given by this, the total flight time. Okay. Now imagine you and your dad sitting in the car, driving at what was it? At this, 100 cos 80 meters per second. So you and your dad sitting in the car, traveling at a constant speed of what was it? 100 cos 80. Okay, yeah, so after 1 second, you and your dad would have covered 10 cos 80, and next second you would have done another 100 cos 80, and then another second late. Well, now that you know the total flight time is this, well, just get this times by the speed here. Okay, so get this times by the speed. So the range would be equals, well, get this here, 20 sine 80, 20 sine 80, and then times it by the speed here, 100 cos 80. Okay, so at the moment it's this times this times this times this. So let's merge these two together. So that's 2000 sine 80 cos 80. So that would be your range. Now jump to your calculator. Well, so do it whichever way you want. It's basically this times this, because sine 80 is just a number, cos 80 is just a number. It's just guessing those three numbers, multiplying each other. So 80. I'm gonna, well, do whichever way you want. This is cos 80. Where's memory plus? Memory plus. Cancel. Hang on. What was it? Hang on, let me start again. Memory cancel. Okay, hang on. 80. Cos 80 is this. Okay, put it in memory. Memory store. Okay, it's in memory now. So now sine 80. Sine 80. Sine is here, and then times it by memory reveal equals this. I hate this calculator. Hang on, let me start again. Memory reveal is this. Yep. Okay. Hang on. So 80. 80 sine 80 is this. Okay. Times my memory reveal is this, equals this. Okay. And then times 2000, and then times 2000 equals this. Equals 342 meters. So going back to our problem here, hang on, the answer is 342. Okay, 342. So the range is 342. So again, we missed it. Even though I increased the speed from last time, but I changed the angle. So it's really doing this. It travels higher. Well, hang on. Last time it was something like this. Last time it traveled something like this. I then increased the speeds, but then I also increased the angle. So what the cannonball has done is it has traveled higher, but then the range is well, it's still shorter. So basically, we still haven't hit our guy yet. our guy is standing 500 meters away, and our range here is only 342. So again, we'll miss them. Maybe we can increase the speed next time, and then decrease the angle. Because if you increase the angle, all that you're doing is that you're shooting the cannonball higher, but then the range will be shorter. So maybe next time I'm going to increase this and and decrease this. Okay.